Hi parents. This is our video for our homework this week. It is the last homework before Thanksgiving break, so let's jump right in. First question, it says round these numbers to the nearest hundred. I know on the kids copy it might say found. That was just a little typo. Our first step is we need to go ahead and label our place values. So we have our ones place, tens, hundreds, and so on and so forth. But when we look at our question, we are rounding to the nearest hundred. The digit that is in our hundreds place is 1. And the place value that tells our hundreds place what to do is the tens place. So I bring my attention to that. And then we need to ask ourselves, is 4 in between 0 through 4 or 5 through 9? It is in between 0 through 4, and we know 0 through 4, we add no more to that place value that we need to round to. So my 1 is going to stay the same. Everything behind it becomes a 0, and then every number ahead of it stays the same. Okay, so that's our number rounded to the nearest hundreds. Next question, we have write the following numbers in expanded notation. What we've noticed in the classroom is that the kids, it's not that the concept is hard, it's more so remembering that vocabulary. So expanded notation, right? We're stretching the number all the way out. Okay, so not just expanded form, but expanded notation. Again, place value is going to be super important. So we're going to go ahead and write our place values. Ones, tens, hundreds, thousands, 10,000, 100,000, million, 10 million. All right. And then let me make my pen a little bit smaller because we're going to have a lot to write. We look at our greatest value, which is 10 million, right? How many 10 millions do we have? 9. So 9 times 10 million. Okay, first step. Plus 2 times 1 million. Plus 4 times 100,000 plus 9 times 10,000 plus 8 times 1,000 plus 5 times 100 plus 2 times 10, and then we don't have any ones to represent, so we don't have to add that into our expanded notation. So again, just the kiddos remembering that expanded notation is stretching that number all the way out, and we have to represent the digit multiplied by the value. Okay, so stretching it all the way out. All right, find the product. Vocabulary word. That means the answer to a multiplication problem. Okay, we can solve this 2 separate ways. Whatever way the child is comfortable with, that's the way we want them to solve it, okay? We're really trying to build up that confidence. We have our area model. And we have noticed that the kiddos do gravitate towards this strategy a little bit more. And that's basically just representing, well, decomposing your numbers. It's just decomposing your numbers. And then finding your partial products. So, for example, 47, 40 plus 7, 36, 30 plus 6. And then I do want to really emphasize on the way that we use our area model. So it is, let me get the highlighter so y'all can see the color. 40 times 30, 40 times 6, right? That's the length times width, length times width. And then for the second row, we have 7 times 30, 7 times 30, and then 7 times 6, length times width. And then once they find that, they'll add up all their partial products, okay? So for example, 40 times 30, we know that 4 times 3 equals 12, and we have 2 powers of 10. And then 40 times 6, 4 times 6 equals 24, and we have 1 power of 10. Then we come down and we have 7 times 30. 7 times 3 equals 21, 1 power of 10. And then 7 times 6 equals 42. And they would come over here to the side and add up their partial products. Okay. And then the other way that they can solve, which you guys might be a lot more familiar with, is just standard algorithm. Oops, sorry. 47 times 36. And I don't want to bore you with this process. If your baby is confident with this strategy, they are more than welcome to use it. But if not, then they can stick with area model. All right, our next one is a word problem. Houston Oaks Country Club has paddle boats that holds 4 people. A group of 459 people want to rent boats. How many boats will they need to hold all the people? Okay, so this is very important because it's not only a division problem, but also interpreting a remainder problem. And on our in the module that we just had, that was very difficult for the children. I feel like they're getting they're understanding when they need to divide, but then after you divide, really taking the time to answer what the question is asking. And it's very difficult. It's very difficult. So let's start off with drawing our strip diagram. We know that our total is 459 people. And then on one boat, 4 people can fit. And we don't know how many groups or how many boats we're going to need to rent. That's what we're trying to figure out. That's how we answer our question. So we're going to divide 459 divided by 4. Okay, and then we just go through the standard algorithm process. How many groups of 4 can I create from 4? 1. Sorry. Oh my. Hold on. 1. Good. 4 times 1 equals 4. 4 minus 4 is 0. Bring it down. And then do that process again. How many groups of 4 can I create from 5? Again, 1 group. 4 times 1 equals 4. I'm subtracting. 5 minus 4, 1. Drop down my 9. And how many groups of 4 can I create from 19? And that will be 4 minus 16. And you'll have a remainder of 3. Okay? So our quotient is 114. And our remainder equals 3. But then when we go back to that question, we're asking how many boats will they need to hold all the people? So basically right now from our quotient, our remainder, we understand that we're going to need 114 boats But there will be 3 people left over. And, we posed a question. Do we just leave those 3 people behind? No. We need another boat for them. And here's where it gets tricky, because we're noticing that the kiddos want to add that 3 to our remainder, but we know that one boat can hold, again, 4 people. So that means I only need one more boat. So to hold all the people, I'm going to need 115 boats to hold all the people so that nobody is left behind. When we move down, we're just, again, spiraling difference and sum. Difference, answer to subtraction. Sum, answer to addition. I think the kiddos are very, very strong in this, in these TEKS, but we're really just trying to emphasize them lining up their place values, because they can subtract and add very well, but if their place values are not aligned, that's where the mistakes come. So even if they write it big to make sure that their place values are lined up, that is so important. Okay, even with the adding, 254,967 plus 83,520. Making sure to line those up. And here we're going to subtract for difference, and then here we're going to add for sum. All right, we've made it to our last 2 questions. Word problem again. A movie theater has 2 rooms. Room A has 9 rows of seats with 18 seats in each row. Room B has 3 times as many as room A. How many seats are there in both rooms? Okay, so this is a very loaded question. We have to first draw a strip diagram, and we're going to represent room A. And from our information, we know that room A has 9 rows of 18 seats, okay? So I know that in my room A, I have 9 rows, and in each of those rows, there are 18 seats. So to figure out room A, I will have to do 9 times 18. And then it says room B has 3 times as many seats as room A. So for B, 1, 2, 3. Because we know that 3 times as many means times 3. And then our question says, how many seats are there in, both rooms? So I'm looking for the total of both of those rooms. All right. So it's kind of like a 3-step problem. I'm going to use the space up here, and maybe even some down here so that we can solve it. Our first step is to calculate how many seats are in room A. So we're going to do 9 times 18. I'm just going to do 18 times 9. Okay. For the kids to help them out, write out their multiples of 9, because they do struggle with it just a little bit. So we have 9, 18, 27, 36, 45, 54, 63, 72, 81. All right. 1, 2, 3, 4, 5, 6, 7, 8. Okay. 2 goes in my ones place. 7 comes up. 9 times 1 equals 9 plus 7. 16. Great. So how many seats are in room A? 162. But we're not done yet. No. Now we have to put 162. 162. Because it says in room B there are 3 times as many. So that means 162 times 3. All right. I'm going to come up here, do that work again. And I'm just using standard algorithm for time's sake. But again, if they still want to use the area model, that's fine. And they can just go up to the previous question to remember the steps and strategies. So we have 162 times 3. 3 times 2 equals 6. 3 times 6 equals 18. 3 times 1 equals 3 plus 1, 4. Alright, so 486. Whew. But we are still not done because, again, our question says how many seats are there in both rooms? Okay, so now that we have both of our totals, we are going to add them together. 486 plus 162. 6 plus 2, 8. 8 plus 6, 14. I'm at 1. 4 plus 2, 6. So there are 648 seats in both rooms. Alright, and then last but not least, write a rule that can be used to find the output number when the input number is given. So again, we're just finding those relationships. What we want the kiddos to see is our numbers are getting smaller when we're moving from input to output. So when our numbers are getting smaller, the only 2 operations that we can do is division or subtraction. And our rule must stay the same. So they need to ask themselves, what is the relationship of 48 and to 4? And then see if that relationship is the same from 84 to 7. And if so, write that rule right here in the middle and find those missing numbers. Okay, so for example, 48 divided by 12 equals 4. And then if I come down here, let's see if 84, or we could even do the inverse operation. So 7, because we don't divide by 2-digit numbers. So let's see if 12 times 7 equals 84. 7 times 2 is 14. 7 times 1 is 7, plus 1, 8. It does, okay? And that's just the inverse operation. But divided by 12 is our rule. So we're going to have to use, again, that inverse operation. What times 12 equals 60? 11 times 12 equals what? And then what times 12 equals 168. All right, guys, I hope that helped you all a lot. Again, this is our last homework before Thanksgiving break. We have been seeing the improvement in the kiddos that do watch the videos. So we are so happy that these videos are helping you guys at home. Thank you so much for your time. Bye.